Now, to summarize, this video happens after students have watched this video, have seen this post and saw this as well as that, and were given the puzzle. And in this week's post, it also says that there, and it's explained in this video. One cool piece of synchronicity is I was working on this Saturday, this week's post during MacLab Saturday School. I was working on this, and I had come up with all of this plus this image prior to receiving Dave's email. And I find this very synchronous with the subject matter we're going to cover right now. So let's get to it. Here's the original puzzle. And remember, I've thrown in a curveball into this puzzle for my students because we're an open book class and they can look up the answer on the internet. And I want to see who's paying attention. So let's go to the explanation. And this is supposed to be algebra. And again, I don't understand algebra. So I'm going to do my best to explain this. And please forgive my errors. Not mathematical, but my explanation. So if a horse equals X, and here are our horses, and we have 3 of them, and the answer we know is 30, then we simplify the equation by dividing both sides by 3, and we arrive at 1x, which is just x equals 10. So if x equals 10 and a horse equals x, then a horse equals 10. So we can look at our little puzzle here and replace the horses. Everywhere there's a horse, we can replace them with a numeral, which makes our job much simpler trying to figure out this problem. All right, we'll scrap that and move on to the horseshoes. So here's our equation, and you can kind of look at this and know the answer. I kind of skipped a step here. It's really 10 plus 2y plus 2y equals 18, but 2y and 2y is 4y. So let's simplify that by subtracting 10 from both sides and then dividing both sides by 4, and we get y equals 2. And if the horseshoe equals y and y equals 2, then a horseshoe equals 2. And we can look up here, and everywhere there are 2 horseshoes, we have 2 plus 2. So we're able to substitute the numeral 4 for those horseshoes. And where there's a single horseshoe, we know that's worth 2. Okay, we're almost there. Let's clear that and head up to the boots. And if the horses were X and the horseshoes were Y, the boots are Z. And here's our Z, which we can look at and just know the answer. This actually, for me, this makes it way more complicated trying to do it this way. But hey, it's algebra, so this equals this. And then we want to simplify, so let's subtract 4 from both sides to get rid of that one there. And now, here's where I'm lost. I mean, I know that that has to be a 1 because these two are equal. Do you put the negative 2 over here as a denominator and 2 negatives make a positive? And is that how that gets to 1? I figure that must be it. So if z equals 1 and a boot equals z, well, then we know that a boot equals 1. So everywhere there are 2 boots, we can do 1 plus 1, which is 2. And when there's 1 boot, we have a 1. Now, I mentioned I threw in a trick. Here's the trick in this problem, because it's not fair. Who remembers algebra? I mean, seriously, who remembers? And speaking of remembering, do you remember? We're trying to solve for this symbol, right? I have said solve for the question mark again and again. All right, so our answer, here we go, is, we'll start just like we have before by taking the graphic and putting it up here and giving a letter. And let's use A for answer. Now, so the problem is stated like this. And in the West, we're going to say 1 plus 10 is 11 times 2 is 22. That's the trick, because you got to remember that multiplication and division happens before addition and subtraction unless there are parentheses. So unsaid in this equation are these parentheses, which means you got to do 10 times 2 first, then add 1. So we can come up with our answer, which is 21 equals A, right? And this is where everybody stops. But this is where my mind kind of exploded because I said, hey, wait a minute. Remember this? Remember that 2 horseshoes are different than 1 horseshoe? Remember that? So wouldn't 2 question marks be different than 1 question mark? This is the trick. I run an open book classroom. I never test the kids without allowing them to look stuff up because in the real world, hey, you don't know an answer, you look it up. I should have looked up the -2 over -2. So, hey, guilty. I plead guilty. So the real answer is not 21 for this question, for solving for the question mark. It's actually 21 equals 2A, which means we got to simplify this, divide both sides by 2, and the answer is 10.5, is what 1 question mark equals. I know, not fair, but what in life is? And I wanted to see how many kids could pay attention and realize this difference here, because this is where my mind exploded and I started thinking, oh gosh, I didn't take into account that 1 boot and one horseshoe the first time. I didn't take into account the 2 question marks. For me, anyone who's observant would be bothered by this because it should just be 1, shouldn't it? Anyway, that's my fun with algebra, and I don't know how the kids did, so we'll see because I recorded this video prior to the day happening.